Alright everyone, welcome to day 16 of Advent to Code. We have 10 days left. We're almost there, almost the home stretch. Some time here. For yesterday, day 15, I should go through and make kind of, not really a visualization again, this is more of a debug. But I went through and made it. As you see, this is my input from the day. And you can kind of see, you can step through all of the operations and kind of physically see how the code would input the stuff into the boxes and how it handles each operation. So I guess if you want to understand the question more from a perspective of what's actually doing, you can do this. If you want to help debug your own inputs to see where your code's going wrong, you could use this. So again, not really much of a visualization as much as just like a fancy debug operation screen or whatnot. But these have been fun to make, fun little challenges, I guess, in addition to this. But we'll see. We'll see if maybe some of the other days will have a better kind of visualization, full scale of this. But at any rate, 40 seconds here. I guess I will cut to when this starts. Alrighty, and here we go. Day 16. Beam Lake, completely focused somewhere. The reindeer leads you deeper still into a lava protection facility. At some point, you realize that the steel facility walls have been replaced with a cave, and the doorways are just cave. The floor is a cave, and you're pretty sure it's actually just a giant cave. As you approach, basically the heart of the mountain, you see a bright light in the cavern up ahead. There you discover that the beam of light you so carefully focus is emerging from the cavern wall closest to the facility and pouring all of its energy into a contraption on the opposite side. On closer inspection, the contraption appears to be a flat, two-dimensional square grid containing empty space, mirrors, and splitters. The contraption is aligned so that most of the beam bounces around the grid, but each tile on the grid converts some of the beam's light into heat to melt the rock in the cavern. You know the layout of the contraption and puzzle input. For example, the beam enters in the top left corner from the left, heading to the right, and its behavior depends upon the encoder's moves. Empty space, direction, a mirror. The beam is reflected 90 degrees depending on the angle of the mirror. Encounters the pointy end of the splitter. The beam instances is right in The beam passes through the splitter as if the splitter were empty space. Okay, if the beam encounters a flat side of the splitter, the beam is split into two beams, going in each direction of this pointy. Okay. Gotcha. Comes in, down, yes. Beams that interact with other beams. A tile can have many beams passing through at the same time. A tile is energized if that tile has at least one beam pass through it. Okay. Beams are only shown on empty tiles. Yeah. 46 tiles become energized. So, yeah, well, I guess we're just gonna code this up. I don't know what else we'd be doing. So, let's go ahead and create our map, which is gonna be inputs, as always, splitting on new lines, and then mapping this to then take a line and split the line on each individual character. So we have our map. So what we're gonna do is we're just gonna go until it falls out, right? Okay. So we're gonna have to do is let x equals 0, y equals 0. I need to file. So x, y equals 0. Let's x I'll do this just to make life a little bit easier on how these are going to go. So actually this is going to be extra is 1. So what we're going to do is while x is greater than or equal to 0 and y is less than, it's greater than or equal to 0, I don't know why I did less than, and x is less than map 0 dot length, and y is less than map dot length. We're going to continuously just go through and move. So the first thing of each step is to do x plus equals x direction, y plus equals y direction. We're gonna need energized. All right, actually, we're gonna make a type here. These are all gonna change position. So it's gonna be position x 0 y 0. I'm gonna call this change. Yeah, make this a little bit more contained. It's not really necessary, but no read-onlys. And it's gonna be change. Okay. So now we're gonna hold a list of energized, which means position list. Oh, because it's that. Sorry, this is X and Y. It'll change. There you go. And then we're gonna do is energized push position. I don't. That's gonna. Yeah, that's not gonna copy. Okay. Cool. So what we need to do now is interpret what each cell is going to be. So we need const cell is going to equal to map y x we'll call it current square. I don't know. And let's just throw up a switch on current square. No, I'm gonna do a false ladder. I like them a little more than switches. So if the current square is a thing, that's pretty easy because we're just going to continue. Else if the current square is a mirror, so let's start with this one. There are 4 directions in common, so what we need to do is we need to know which direction it's coming from. I'm actually, do I want to change this? Okay, actually, it's fine. We can do this. So if it's coming in from right, so if change.x is 1, what that means is that change is going to be equal to, I'm going to copy this because I'm lazy, y of -1, x of 0. I don't know why I did that. That was totally unnecessary for me to do that one first. Otherwise is if the x is -1, that means it's coming in from that side, the y is going to be that. And then we can go ahead and do these ones. So now we're on to the y's. That means if y is 1, which means it's going up, x is 1, which means that this one is also -1. Cool. There's some logic you can do for this because it's a 90-degree rotation, but it's fine. Okay. Sweet. Now the other way. Need 2 of them. So that means x is there, so that means now it's going to be 1, -1. Y is 1, it's going up, it's going to be -1 and 1. Beautiful. The other two are gonna be this and this. So if X is, oh, it splits the beams, doesn't it? Gosh darn it. It splits the beams. Okay. All right, so we're gonna need a const get new change. Call it new directions. And all of this is going inside here. Because instead we're returning like this. So we're going to need the current square and the change in the current change. And then this is going to return a position array, or yeah. Okay. So everywhere we see change, that gets changed to that. And then all of these get changed to return statements. And when we get down to here, these ones will end up returning multiple. So I'll deal with those in a second. Okay. So now what's going to go here is what we're going to have to do is do change I'm just gonna do this right now because I'm not thinking in TypeScript right now. Equals that, and then chain. What do they call these? Just change. Change for each. These all go into here. So now we have this. Which means that positions is also this. Fair enough. So this is actually just going to become length is greater than 0. Because what's going to happen here is we're going to do position equals position filter to only include the ones that are currently in the map. All right, so and then we're going to need const position equals position get I. Cool. And this is going to be a set. Yeah. For now, we'll do this. I need to remember to make this like a set or something like that. Okay. And so this is going to be get new directions for the current square and the change. Oh, it's backwards. It's like, what? It's because it's backwards. There we go. And what we're going to do is this dot push. I don't think it's gonna like that. I think it's gonna complain that, yeah, it's gonna have to be that, right? There we go. Okay. Good. So now it's gotta finish this. So what's gonna happen is if it's coming from that, we need to return. Oh, but we're not also. Okay. Oops. Because we also need to do new positions, push. Array from length neuters length map to just be position. Cool. And I don't want to forget to do change equals new change directions, and position equals new position. Which actually I can just do this, simplify it a bit. Okay, good. That makes that easier. So now it's gonna be y1 and y-1. The other way is going to be the same thing. Whereas this way is just going to return the current change. Think about that for a second. As long as this is. Which means like these can be condensed. And condensed even further. That's fine. So that means that this one's going to be y and y. It's going to be 1 and -1. There we go. It's actually just going to be returning that. Okay. Solid. All right, so what should be happening now is we get an error. Properties of undefined change. How is change undefined? Reading 16. Oh. Because it's here. Oh. We need another method up here. Just do that. What's going to happen here is make a call to isn't map position, and only if it is, do this. Otherwise, it actually doesn't get added in position, so we actually don't technically need this, because this takes care of the filtering for us. Cool. So that should work. All that's left is now this needs to be a set. Which we might be able to get away with this. I don't know if that'll work, but I don't know if sets by default do those objects correctly. I think it does, because I think it will do shallow copy, shallow checking. So which means case part 1 is just going to be energized size. Shot at 16. All right. Well, I didn't even get one right. One check I get to. That's running for a long time. Okay, something's not... One of these logics is not correct. Okay, that did... Okay, oh no. I need to replace these. Shoot. Let's replace the question marks. Yeah, I gotcha. Okay. Cause strings, they like yeah. Okay. We're gonna change to that. Alright, so I got 17 still. Alright, so I made it through there. -1. That didn't do it right. No, -1 should go to a positive x. Oh wait, no. Yeah. 'Cause that's down. These are backwards. Are these actually the same? No, they're flipped. Well, I was gonna say that was more promising, but no, that's running forever. Gotcha. So there is an infinite loop. I just need to detect infinite loops. Okay. Easier said than done. It would be technically here. Okay. Filter. Can I do has, okay. So filter, this is gonna be redirection, it's gonna be current square does not equal or current, so it's basically saying it's not one of those. It's not one of those. Or energized does not have but new direction. Oh, no, it's new direction there. But I can't do that then. Okay, so I need to do this then. So I need, what's wrong with this? Sorry, it's an and. It's not one of those. So we need, oh. Let's do this. It's going to be position, ND, ND. Okay. We're changing it to this. We are changing it to this. Strings it is. Position X, position Y, and this is ND and ND. Okay. Mention that, and then we're adding position, which I can just partial of that. Okay. No, that's in the wrong spot. It's yeah, because it's removing to here and it's now been visited. And so we're getting the new directions from this spot. Right, it needs to be this. Okay. $45. It's 46 tiles. But I'm forgetting to energize the very first one. So if I do this, will this give me... Please just give me 46. Alright. I don't know why I struggled so much for that. I got back 17 again. Oh. I didn't say something. Too high, though. I must have not saved the change to the question marks. too high. Did I not? Should change to nothing. I skipped right through it. Gosh darn it. Okay. Actually, what that means is we are going to start at -1. There we go. Okay. As you try to work out what might be wrong, the reindeer tugs on your shirt and leads you to the nearby control panel. There, the collection of buttons lets you align the contraption so that the beam enters from any edge tile and heading away from that edge. You can choose either of 2 directions for the beam if it starts on a corner. Any tile in the top row. Okay. What's the... enters the largest number of tiles. Brute force it is. Let's x equals 0 while x is less than map dot length 0. Okay. So what we're actually going to do is I'm going to wrap this up. Const get okay. Take all that, dump that into here. And we're returning energized. Ooh, return. So we're gonna call get energized. We don't change map at all, so we should be good to reuse this. It shouldn't need anything else. So these can that can go away now. I'll take that away. Okay, so what can happen is now we can call... oh, we need to give it the starting position. Sorry. Start... starting position and... the start direction, I guess. So we call it get energized from here. We're going to pass it that... with that. Okay. So what's going to happen here is the top is going to be y1. It's going to start at -1, 0. We need const. We need let max equals 0. Top, bottom, or top, bottom. The bottom is equal to map dot length minus, and then max is equal to math dot max of math dot max of top, bottom, max. Okay, that'll solve the x's. Fingers crossed that's not too inefficient. It should be okay. We should be able to get away with this. -1 map 0 dot length. Actually, I'm gonna do just so I don't have to keep pulling, calculating that. I can do that. Get rid of that. And part 2 is going to be max. So this is going to be left, right, length, 0, 0, 1, -1, 0, 0. Fingers crossed this works. It should be a little slow, but not too slow. So not too slow. It's too low though. Uh-oh. Why is that too low? Oh, I'm dumb. XX, wow, okay. I don't know how, all right. No comment. No comment. Input. Still too low though. Oh, wait, I put the wrong number in. I didn't wait for part 2 to finish. Put the wrong number in. Okay. While it's going. So, anyone can like... Yeah, I make this kind of the way I usually code of the functional base. It might be a challenge. This could be changed to reduces though. But while I do that, before I do that. There we go. Okay, well, yeah, it wasn't hard. I just like, I don't know what I was going. Oh, fancy. Yeah, I'm not sure what was going wrong with me. I don't know. It wasn't. All right. Anyways, yeah. So this is interesting code. It's kind of different, but the point of today is that we're given this input. Typescript, yeah, these strings, they don't like the whole other slash. So all these slashes, the backslashes, yep, got changed to question marks. So that's the only thing different than mine. But to answer the question, we want to follow the paths. When you get to something like the mirrors, you can split on some of this bit. But for the parts, it's pretty simple. I have this get energized function. You pass in the start position and the direction. That way it works for part 2 as well. This get energized position, or get energized function, all it does is it adds the positions it's currently tracking to this. While there's a position, we update it based upon the change to make. So the change in direction, make that change here. We log the position and what direction it's going to a set. That way we can detect loops or infinite loops, I guess. Because if we ever have another beam that gets to this position with the exact same change, we know we've already visited it and it's going in the same direction, so it's going to be an infinite loop. In which case, down here when we get a new position, we can just filter it out and just not continue with it. We have this if here for checking if the position is in the map, because if it's outside the map, now we've left it, and that's how we kind of eventually get all the positions down to 0, either through them being outside the map or them being filtered out because they're in an infinite loop. Get the character. I'll be doing this get new directions is basically map the current character in the square. So if it's this slash, there's some rules about which direction it's going and how it it returns. Same with this one. It's pretty straightforward. It's just on the splits you return 2 directions, which gets handled by the next bits because we just dump those new directions into their changed array. We also dump the positions in. I should probably honestly condense these down to these two down to one array, but for now they're not. I'll probably eventually, I might do that later. Is condense these down to one array, but it's fine as it is. But honestly, that's all it is. I mean, part 2 is just going brute forcing it, always getting the max, and it's not too bad. It's just the infinite loop was a little bit struggle, and I had made a mental mistake, so shouldn't take me long, but I did. But at any rate, hope you guys enjoyed. Day 16's done. See you guys tomorrow for day 17. Peace out.